Hello everyone, good afternoon. I want to welcome you to today's class. In today's lesson, we're going to be talking about stoichiometry. Let's take it away. At the end of this class, we'll be able to apply a balanced chemical equation as a conversion factor to perform mole to mole, mole to mass, and mass to mass stoichiometric calculations using the mole concept and the factor unit method, the factor label method, which we otherwise call, of course, I've told you this a lot, dimensional analysis. That's basically what we're doing here. So in last time in the mole concept, we talked about just a single atom or a single compound and what constituent element it has inside. Here we're going to be looking at a reaction completely, and we're going to be using that to quantify the amount of the reactant or product that are present in the chemical reaction. Let's take it away from there. Let's first of all start from the big elephant in the house. Let's try to disambiguate or try to break down the word stoichiometry. The stoichiometry simply means a quantitative relationship between reactant and product in a chemical reaction. This has to be a balanced chemical reaction. The chemical reaction has to be balanced for this to actually take place. It has to be a balanced chemical reaction. Now, of course, when it is balanced, when you add a coefficient like we did when we talked about balancing of chemical reaction, it is based on those coefficients, and those coefficients will be what will correspond to the mole ratio of those balanced equations. Now, we can interpret that in terms of course, the number of mole concept, which are the coefficients of those balanced equations. We can interpret it in terms of the mole concept and use that to solve numerical problems with factor unit method. Let's see an example of what we have here. So in this reaction now, we know that hydrogen reacts with oxygen to form water molecule. And in a balanced equation here, there are, if we just do the ratio first, there are two. The mole ratio between the hydrogen to oxygen is 2:1:2. So we can interpret this in various ways. We can interpret this in terms of mole ratio to say 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of water. Of course, vapor, which is water gas. So we can actually write a conversion factor based on these relationships. And again, remember, since these are molecular compounds, we can also interpret this in terms of what again? The Avogadro's constant. Now, if this is 2 moles, what it simply means is that 2 times 6.022 times 10 to the power 23 molecules. Here will be only 1 mole of oxygen will constitute 6.022 times 10 to the power 23 molecules of oxygen. And here will also be 2 moles of water, which will be constituted of 2 times 6.022 times 10 to the 23 molecules of water. Now, depending on, we're not going to be spending time trying to look at the particle-to-particle relationship of the reactant and product. Our main focus will be mainly on the moles and on the mass as well. Of course, 2 moles of hydrogen will weigh 2 times, whatever the molar mass of hydrogen gas is. So, but let's just try to start with the mole-to-mole ratios. Let's try to write some conversion factors. So if I want to write the conversion factor between hydrogen and oxygen, there are a few things I'm going to do here. I'm going to try to move this canvas up a little bit to show you what I'm talking about. So if I'm going to write the mole concept between hydrogen to oxygen, I can start by saying that there are 2 moles of hydrogen would divide 1 mole of oxygen. Or I can also say, of course, as we've always done, it can be 1 mole of oxygen to 2 moles of hydrogen. So if I'm solving a problem involving hydrogen and oxygen, this is the conversion factor I'm going to use. If I'm solving a problem, let's say, if I'm solving a problem involving hydrogen and the water molecule here, it is 2:2 ratio. So I'm going to say 2 moles of hydrogen will divide 2 moles of water molecule, or I can also say 2 moles of H2O will be 2 moles of hydrogen. Yes, this is another conversion factor that I can come up with this. Remember, this is all. I can also write it in terms of what about oxygen and water as well. I can write another one. Another conversion factor can come from here. If I compare this to this, I can also come up with, say, 1 mole, of course, of oxygen will divide 2 moles of water. Or I can also say 2 moles of water vapor will be to 1 mole of oxygen. Now, what decide what we're going to use is the only thing that will decide what we're going to use is simple. Is the question we're asked. If you just make the comparison between those two variables and solve your problem. And that's what we're going to be doing. So these are, in this case, we've generated 1. Let me use a different color. We've generated 1, 2, and 3 conversion factors that can be used to solve any problem involving this chemical reaction. So we can do that and actually apply the mole concept to solve the problems as we move on. I'm going to show you as we move. So again, remember this particular table that I've used to solving problem. Again, it's important to always remember this, that there are 5 steps I gave you in solving these problems. The first, of course, part there is to write down what you were given or what you were asked to find. You need to know where you're going to. You write down what you were given. You create a solution plan. From where are you and where are you going to? Then you write down your conversion factor and then solve the problems. And the idea is to cancel the undesired unit and leave the desired unit after doing your numerical problem using your calculator. Now we start with the first part, the mole to mole conversion. That's what we're doing. So we're starting with the mole to mole, which is actually straightforward because here we're focusing on only using the coefficient of a balanced equation. So to convert from mole of A, assuming this is our hypothetical equation, I want to convert from mole of A to mole of B. Let's assume that this is, of course, 1 mole of A and this is 1 mole of B. That is what we are assuming in this case. All right. So what we're going to do is that the mole of, we were given to mole of A. The mole of A is what you are starting with, what you were given. All right. So you are given mole of A. This is the given quantity. This is the given quantity, what you were given. And you are looking for what? The mole of B. Remember, that's what you're looking for, the mole of B. Right? So, but what you're going to do is that you already have a balanced equation whereby this simply means 1 mole of A to 1 mole of B. So what you simply need to do, you can provide a conversion factor here. Let's see the conversion factor. So this will be 1 mole of A over 1 mole of B, or it can be 1 mole of B over 1 mole of A. What we decide what we're going to do is what we're asked to find. Now, between these two, we're going to be using this. Why? Because we're converting it to moles of B. So our B is going to be on top. And if you bring that here, that's what we've done. So moles of B on top, moles of A on top, which is actually 1 mole, 1 mole. And then what happens? Of course, we're given the moles of A. What you need to do is to cancel this. And when you cancel this, we are left with the mole of B. So where do you get this, the other moles? These ones that I highlighted in B, this is being given from what? The balanced equation, which are the coefficient. The coefficient of a balanced equation. Let me write it. The coefficients. The coefficient, let me put that. The coefficient of balanced equation. That is where we get this from. And when you apply that, you get your answer in mole, and this becomes a direct one-step problem. This one does not involve the molar mass because there's no need to do that. Let's solve some problems from here. Okay, the question says, how many moles of water are formed when, so look at what we're looking for. Moles of water is what we're looking for. When 25 moles of oxygen react with hydrogen according to the following equation. Again, what are the two things we're talking about? Let's try to have a relationship. The question is asking us two things. The relationship will be between those two, between oxygen and water molecule. That's the question. So we're going to write the conversion factor for these two, right? The conversion factor for these two will be, of course, 1 mole of oxygen, 1 mole of oxygen over 2 moles of hydrogen. Oh, I didn't put the moles. 2 moles hydrogen. Or it can be, on the other hand, 2 moles of hydrogen over 1 mole of oxygen. That's what we have there. Now, what is going to decide what we're going to use is what we want to. So since we're looking for the moles of water, we're going to be using, of course, okay, remember this is 2 moles of H2. I didn't put it there. 1 mole of this is H2O, please. I don't know why I didn't put that. So it's 1 mole of oxygen over 2 moles of H2O, and then 2 moles of H2O over 1 mole of oxygen. So we're going to be using this conversion factor because that's what that's what I do when we're solving for the moles of water molecule. Let's follow the part. Let's try to write out what we're given. The first part, we're asked to find moles of water. That's what we're looking for. That's what we're asked to find. The first thing. In the second thing, remember, I'll try to list them out. What were we given? We were given what? 25 moles. 25 moles of what? Oxygen. Oh, I don't have to write it. Moles of oxygen. That's what we're given. In the third step, following the chart, we have a part. So the part is that we're going from moles of O2 to what? Moles of H2O. That's what we're looking for. That's the part. We're going from moles of O2 to moles of this. And then, what are we going to do next? We're going to try to find out what is our conversion factor. The conversion factor we're going to do is the one that has what? Water molecule on top, which is this. We'll bring it in this step. So here we're going to be using the 2 moles of H2O over 1 mole of oxygen, because that's what we need to cancel out. So what we're doing is, in the fifth one, we now solve the problem. I'm going to solve it here. To solve the problem, you write down what you were given. We're given 25 moles of oxygen. We draw a line. What is going to be, we're using this one. So we write it down here, 1 mole of oxygen. See, this will cancel this. And then we'll have 2 moles of H2O. And then this cancels this, and your 25 times 2 will give you what? 50 moles of water of H2O. That is how you solve. So solving problems in mole-to-mole conversion is very conceptual and straightforward. So, and you don't have to sweat out a lot in doing those problems. Let's look at problem 2. In problem 2, it says how many moles of hydrogen are required to react with 25 moles of oxygen? Again, here we're looking at hydrogen and oxygen. So you write the mole, just write out your conversion factor between those two. So between those two, of course, you're going to have, in this one, you're going to either have 2 moles of hydrogen over 1 mole of oxygen. Or you're going to have 1 mole of oxygen over 2 moles of hydrogen. Those are the two conversion factors. And what we decide what you're going to use is you're looking for how many moles of what? Hydrogen. So that means we're going to be using this one. It's going to be on top. All right? So let's write out everything. First, we're asked to find the moles of H2. B, the next thing we're going to do is that we're giving what? 25 moles of what? Of O2, of oxygen. Is given right there. 3. C. Then, what is our part? We're going from actually moles of oxygen to moles of hydrogen. That's what we're going to. And then, we already wrote out our conversion factor. We're going to be using this guy. So, it's going to be 2 moles of hydrogen divided by 1 mole of oxygen. And the last part, the fifth one, we don't solve the problem. You start from what you were given, which is 25 moles of oxygen. Then you bring down the conversion factor. Of course, 1 mole of oxygen will be low. And then 2 moles of hydrogen is going to be on top. And when you do your math well, this oxygen, moles of oxygen cancels moles of oxygen, and you're going to have what? 50 moles of H2 hydrogen. That becomes your answer. So the mole-to-mole conversions are actually straightforward, very straightforward. Let's do another problem here. In the second one, the same thing we're going to do. Of course, in this case, it says how many moles are generated from 12.5 moles of what? P4 according to this. So how many moles of this? So what are we looking for? In the first part, we're looking for moles of pH3. That's what we're looking for. Then 2, what were we given? We were given 12.5 moles of P4. In 3, we create a part. We're going from what we were given, from moles of P4 to what? Moles of what? pH3. That's what we're doing. And then let's write the conversion factor. In the conversion factor, we're considering these two. Since we're considering those two, what will be the mole ratio? We're going to write this on top. So it's going to be 4 moles of pH3 will divide 1 mole of P4. And 5, we solve the problem. How do we solve it? We start with what we're given. It's going to be 12.5 moles of P4. Draw a line. You're using this one. What it means is that a mole of P4 is going to be down, whereas 4 moles of pH3 is going to be up. This, we cancel this. And then, if you multiply 12.5 times 4, this is going to give you actually 50 moles. 50 moles of pH3. You do not need to actually show it in the number of significant figures. Just to let you know, you can just say 50 moles of pH3, and this becomes our answer. All right, again, I put this concept, I try to provide enough information, just enough examples, so that as you go through, you can pause the video and actually practice the problem yourself even before you see my solution. In the next question, just exactly the same thing, still mole to mole. It says, how many moles of hydrogen are needed to react 12.5 moles of P4? Again, without everything out. In the first one there, we're looking for moles of hydrogen. That's what we're looking for. 2, what were we given? We're also given 12.5 moles of P4. That's what we're given. C, what is the part? We're going from moles of P4 to, so we're going from moles of P4 to moles of hydrogen. So we're considering these two. That's what we're doing there. This 2 is our interest in this case. That's 3. And 4, what do? We use the conversion factor between the two. These two, since we're looking for what? Hydrogen. Our hydrogen is going to be on top. So it's going to be 6 moles of hydrogen divided by 1 mole of our P4. That's our conversion factor. So what do we do in the 5th part? Just plug it in. Let me put this here. So in the 5th step, we'll plug it in. So it's going to be 6 moles. No, that's not what we're doing. It's not 6 moles. What we're given is going to be 12.5 moles. 12.5 moles of P4. Then, using our conversion factor here, 6 moles of hydrogen on top, and then 1 mole of P4. Mole of P4 cancels mole of P4. 12.5 times 6. And when you do that math well, this will give you about 75. Of course, 75.0. Or you say 75 moles of H2. This becomes our answer if you plug that in properly in your calculator. So again, remember, there are 2 conversion factors here, but the why we use this one is the one that has the hydrogen on top. All right, let's go to the next thing. Now, so we can start introducing extra steps in this now. In this case, we're talking about mole to mass conversion. What does that simply mean? Is that we're going to be giving something in mole, and then we're going to take it to the mass. But in this case, we have to use the molar mass of B. So we're not going to use the molar mass of A because the problem will be given in moles of A. But to convert it to the mass of B, we have to bring in the molar mass of. So what we did was to expand the previous graphic I showed you by an extra step. So we started with this guy. This is what is given. This is from the mole ratio. This is mole ratio of balanced equation. That's what we get that, which is of course here to be 1:1. and then it will give us mole of B, but we don't want to stop there. To cancel mole of B, we know that the mole of anything, any substance, is equal to the molar mass of that. Of course, the molar mass will be in grams. So that's what we use. So 1 mole of this will give us the molar mass. This is the molar mass, has to be on top. And then when you do this, this will cancel and give us the grams of B, or the mass of B down. So we're going to try to use this scheme again in the next step using the problem we're going to solve. Let's see how that goes. Again, remember, this simply means the molar mass of B. That is how we got that. This means the molar mass of B. All right, let's do that. So let's use this problem. It says, what mass in grams of oxygen, that's what we're looking for, are needed to react 6.25 moles of propane in the provided balanced equation below? The equation is balanced, but we're looking at two things. It says, what mass of oxygen? So we're looking at oxygen reacting with what? Propane. Those are the two things we're interested in. And the ratio is 1:5. So now we're going to, since these are the two things that we are concerned with, let's try to write out a few conversion factors. Now, first of all, there is mole to mole, and there is also mass. The first mole to mole we're going to deal with there is, we know that when we, let's calculate the molar mass of oxygen. So oxygen simply means 2 times 16.00. That's going to give us 32.00 grams per mole. So having said that, we can write out a few conversion factors. We know that a mole of oxygen, of course, will give us 32.00 grams of oxygen. And we also look at the relationship, the mole ratio between these two. It's easy. We know that a mole of propane, that's propane gas, a mole of propane as in use for a grilling, a mole of C3H8 will also give us what? 5 moles of oxygen. That's the mole ratio. So these are the two conversion factors we're going to use. And like I said again, what matters, the one that's going to be up or down, is what you want to eliminate. So first of all, let's write everything out. In the first step, we're asked to find the mass or grams of oxygen. That's what we're looking for. That is this. That's what we're looking for. 2. What is the next step? The next step, you know, what were we given? We're given what? 6.5 moles of propane. So we'll write it down. 6.25, not 5, moles of C3H8. What's the next one? The next step. The next thing, what is the part? Now, look at this. The part is that we're going to start from here. We're going to go to the mole. From mole of B, we're going to get to the mass of B. So let's do the part. The part will be, we're going to start from moles of propane, C3H8. Of course, if you start from mole, you have to go to the mole of the other one. So we're using this first conversion. Okay, no, this is the first conversion we're going to use. We're going to use this one first. And then secondly, we're going to use this one second. So we're going to use one. No, we're going to number it. We're going to use this one first, and then we're going to use this one second. No, that's, oh, what am I doing? It should be 1 and 2, 1 and then 2. Go from mole of propane to what? Moles of oxygen. That's what we'll do first. And then we're going to go from moles of oxygen to mass or grams of oxygen. Of course, here we're using, this is the mole ratio, which is this is on this. That's what we're using. In the second one, we're using the molar mass, which is what I already showed you here. So let's write it out. Then number 3, I'm going to put my 3 here, shift it a little bit. No, number 4. So what are the conversion factors we're going to use? So the first we're going to use, since we were looking for oxygen, our oxygen is going to be on top for the mole concept. So we're going to have 5 moles of oxygen over 1 mole of propane, C3H8. Remember, this is what we're using here first. This is the first guy we're using. That's it. That's what I'm using first. And then secondly, now to convert it from mole of oxygen to mass of oxygen, we'll now use this one. And in this one, we're going to put the mass on top. We're looking for the grams. So we're going to say 32.00 grams of oxygen over 1 mole of oxygen. Again, we're using the second one here in red, because we're looking for the mass, the grams has to be on top. So let's plug everything in and then write it out. I'm going to move my canvas a little bit to give myself some space. I'm going to move my canvas a little bit and give myself some space. So let's start. In the first one here, we're going to say, am I going to have enough space to do that? Okay, I will. I'll just move it as much as I can. It doesn't matter. Yeah, it's a video that I'm recording, so you will always see this. You would have seen it already. And you have the note on canvas as well. So we're going to start from what was given, which is the fifth step. In the fifth step, so we're going to start with what? 6.25, what was given? Moles of C3H8. We're going to do this. I'm going to move this a little bit up again. All right. So now, this is the first conversion factor we're going to use. So we're going to bring this here. So it will be 5 moles of oxygen over 1 mole of C3H8. Again, this we cancel. Now we have it in mole of oxygen, but the answer didn't say we should stop at mole of oxygen. We want it to in mass of oxygen. We're not going to use this as a second. Again, this is the first one. This is the second conversion factor. So it's going to be 32.00 grams of oxygen over 1 mole of oxygen. Again, this will cancel this. And when you multiply 6.25 times 5 times 32, you're going to actually be getting approximately 1,000 grams of oxygen. And that becomes your answer and how you solve the problem. And again, like I said earlier, always feel free at any point in time to pause this video, to try this yourself, and then keep working on it as well. All right. Okay. Having said that, we now move over to, I want to make sure that you guys can see this. I'm not cutting stuff that much. All right, let's move over to the next problem. Now, in the next problem now we expand it. Remember before, in solving for the mass, the mole to mass, we expanded it to the right? We expanded by adding this. Interesting. Oh, that is, I didn't know it was not on my canvas. My bad. Okay. So we expanded to the right by adding this. Now we're going to expand to the left by adding this. That's what it means. So we're converting from what? Mass of A to the mass of B. That's what we're doing. So this is the longest scenario that we're going to do. Again, the first thing you need to know here is that you're going to use the molar mass of A. So here you use the molar mass of A. So this is the molar mass of A. Then here, of course, in the middle here, you're going to use the mole ratio from balanced equation. Mole ratio of balance. And here, of course, we talked about this earlier. Here, this will be the molar mass of B. And like I said again, when you finished all your calculations, everything here is going to be left with what? Grams of B. Let's see. Let's try to cancel. So if grams of A cancel grams of A, you're going to have mole of A. Mole of A cancels mole of A. You're going to have mole of B, which is what we have here. If mole of B cancels mole of B, we're going to have what here left? So if this cancels, we're going to have mole of B left. And then you cancel mole of B cancels mole of B. You're going to have your grams of B left, which is now our final answer at this point. So what we've just simply done in this case is to expand it both to the left and to the right to make sure that everything it goes from mass to mass by bringing in both the molar mass of A and the molar mass of B. Let's take this to a conceptual example here. So the first question says, how many grams of water are formed from 4.7 grams of oxygen according to the following equation? So what the question says, how many grams are formed from 14.4 grams of this? So let's try to write out all we need. So in this case now, the two things we're interested is water and what? Oxygen. So what it means is that we're going to calculate the molar mass of those two. That's the first step. We're going to calculate the molar mass. Let's do it here. So the molar mass of oxygen, I did this before earlier, simply means 2 times 16.00. This will give you, of course, 32.00 grams per mole. And then if you do the molar mass of water, I'm going to go back to my green. The molar mass of water, of course, will give you 2 times 1.01, which is hydrogen, plus 16 of 0.00. This will of course give you 18.02 grams per mole. So we have the molar mass of those. And the next thing we're going to know is that since we're talking about oxygen and this, we're going to use them, of course, again, we're going to use the 2 mole ratio. So let's write out all we need in this guy. What are all the conversion factors we need? The conversion factor we need will be, the first one is that a mole of oxygen is 32.00 grams of oxygen. The second one we also have here is that a mole of water will give us 18.02 grams of water. And then the last one is that since we're looking at this, we're going to look at the relationship. Will be the 1 mole of oxygen will give us what? 2 moles of H2O. So we're using 3 conversion factors to get through this problem. Let's write out all we're given. In the first one, in number 1, the first thing we're given, what are we looking for? We're looking for the mass, or you say grams of water. That's what we're looking for. That's what we're asked to find. To what were we given? We were given grams of what? Oxygen. So we're given the grams of oxygen, which is here 14.7. That's what we're given, grams of oxygen. And then what is the next thing is that we now do the part. What is the part? 3. We create the part. What part are we creating? We're going from grams of oxygen. So to create the part, we're going from, first, let's look at this. So first we go from grams of A to mole of A. That's the first thing we're going to do. So we're going from, first of all, grams of oxygen, we go to mole of oxygen. And then from mole of oxygen, we go to mole of water. And then from mole of water, we now go to mass grams of water, which is exactly what we have here. You go from grams of A to mole of A. You go from mole of A to mole of B, and you go from mole of B to grams of B. Of course, this will be from mole ratio. This will be from the mole ratios. No, sorry. This will be from molar mass of oxygen. This will be from mole ratio. Then this will now be from molar mass of water. And we got all those things written in our conversion factor. So the first step we're going to be using this one. Second step we use this. And then in the third step we use this. So we can say this is 1, this is 2, and this is 3. That's what we're going to do. So let's do it. Let's start. So, and then let's not, so those are our conversion factors. So the fourth one is our conversion factor, which we will not have all here. I'm going to leave it there, we already have it. So in the fifth part, we now apply everything and begin to solve our problem. So let's do it. To solve our problems here, let's plug it in. So we're going to start from that one. So the first thing, we start with what we're given, which is what? 14.7 grams of oxygen. We're going to convert it to mole of oxygen. So of course we're using this. So we know that we're going to, since we want to remove the mole, no, my bad. We want to remove the grams. We want to remove the grams. So look at it. So the grams is going to be down. That's 2.00 grams of oxygen. 1 mole of oxygen. This, we cancel this. The next thing, we're going to go from mole of oxygen to mole of water using the mole ratio, which is in the second part. So since we're looking for water, water is going to be on top. All right? So, no, we're going to use, this is 1. Oh, I made a mistake here. Okay, so this will be, we use this one first. We use this second as 2, and then we use this last. That's what we'll do it. So in the second part, we're using the mole ratio. So the mole ratio will be 2 moles of, no, not 2 moles, that's 1 mole. Or let's just start it like this. So it's going to be a mole of water, because we want water to be there. We're eliminating hydrogen, oxygen. 1 mole of oxygen down. Look at it, this eliminates this. And then we have mole of water. Then we're going from mole of water to mass of water. That is now when we use this one. So it's going to be 1 mole of H2O and then 18.02 grams of H2O. Let's see, this cancels this. What can you see? All our undesired unit have been cancelled. We're now left with the mass or grams of water, which is what we're looking for. And when you do your math very well, you're going to actually get 16.6 grams of H2O. That becomes your final answer. So the idea here is to know what you were given and what you asked to find, and be able to create a clear path on how you get there. Let's take more examples. Here in reflection 6 here, we're just basically doing exactly what we've done. Again, it says how many grams of hydrogen are required to react with 14.6 grams of oxygen according to the balanced equation. So our worry here again is between these two and these two, which I've already calculated everything. Okay, hydrogen, to calculate the molar mass of hydrogen, I'm going to do that one. Simply what it means is that 2 times 1.01, which gives you 2.02 grams per mole. So what it simply means that a mole of hydrogen gives you 2.02 grams of hydrogen. So we know that already. So I'm going to try to make this a little bit faster here, just to favor the time for our recording. So in the first step, of course, we're looking for grams of hydrogen, which is a question. B, what are we given? We were given again 14.7 grams of oxygen. C, what is our part? Our part will be, again, we're going to go from grams of oxygen to the mole of oxygen. That's the first thing you do. From mole of oxygen, you go to the mole of hydrogen, because we're comparing these two. And from mole of hydrogen, you now go to grams of hydrogen, of course, using the molar mass of hydrogen. So that is the part. And then the conversion factor we're going to use. What are the conversion factor? We're going to use two conversion factors. We're going to use the first conversion factor will be converting 1 mole, of course, of oxygen will give you, we wrote this earlier. And then we're going to use the mole to mole ratio. We're also going to use this one. Is that 2 moles of hydrogen is equal to 1 mole of oxygen. And finally, we're going to use 1 mole of hydrogen is equal to 2.02 grams of hydrogen. And the last, number 5th one, we're going to solve. Let's try to solve this. Let me give a space here. Go to create a boundary here. So the 5th one. Let's try to solve. So it's going to be, let's start. We start with what we're given 14.7 grams of oxygen. We convert it to mole of oxygen. So it's going to be 1 mole of oxygen over 32.00 grams of oxygen. The next step, we now go from, this will cancel. We now use the mole ratio. What's the mole ratio? The mole ratio between this is what? 1 mole to 2 moles to 1. So it's going to be 2 moles of hydrogen over 1 mole of oxygen. This will cancel this. And finally, to convert from mole of oxygen to mass of oxygen with the molar mass, and we're going to remove the mole, which is 1 mole of hydrogen. That's what we're using here. And then we put 2.02 grams of hydrogen. This will cancel this. And when you put this in your calculator and do your math right, you're going to get 1.86 grams of hydrogen is needed to react 14.7 grams of oxygen according to that balanced equation. That is what you're going to have. All right. Again, at this point, we're just solving problems to make sure that you get more competent in this. But the lecture is almost done. It's just constant practice and solving of problems will help you know all the bits and pieces of how these problems are solved. We'll now go to the next reflection 7. The question says, determine the mass of pH generated when 10.3 grams of P4 react with excess hydrogen to form the following, to form pH according to the balanced equation. So it says determine the mass of this generated from this. So we're interested in this guy and this guy. Again, remember, since we are talking about this, what the first thing we do? The first thing we do is to calculate the molar masses of those guys. Let's start. So the first of all, let's calculate the molar mass of P4 will give us 4 times 30.97 will give us, that's P4, will give us 123.88 grams per mole. The next one, let's do pH3. Molar mass of pH3 will be Phosphorus is 30.97 plus, there are 3 hydrogens here, 3 times 1.01. That will give us actually 34.00 grams per mole. So we have those. So we're basically, I'm going to make this a bridge. We're going from mass of P4, which is grams of course, to mass, or which is grams of pH3. Again, I'm not going to write the part like I broke it down in the other ones, but you can always go through my table, the conceptual way of doing it step by step. So here, I'm going to try to speed it up a little bit. So let me start with this guy. So I'm going to start with the mass. So 10.35 grams of P4. First of all, convert it to mole of P4, right? We know that a mole of P4, like I calculated, will be P4 will be, the molar mass will be 123.88 grams of P4. Again, this, we cancel this. Now, let's go to mole ratio. We're talking about two things, right? Our interest here is that we're talking about between this and this. So let's move, since we're looking for this guy first, we're going to put this on top. So this will be 4 moles of pH3 is to 1 mole of P4. Again, a mole of P4 will cancel mole of P4. And then finally, we now go to the last. We want to remove moles of pH3. And to do that, we're going to be using what? We're going to be using the molar mass. Let me put it. The molar mass, which is this, the molar mass of pH3. So let's do it. So it's going to be 1 mole. Of course, we're going to remove the mole. So 1 mole of pH3 is cancelled out. And the molar mass will be 34.00 grams of pH3. So this will cancel this. And you see, everything we don't need is cancelled. We're now left with grams of pH3 that we want. And when you put this in your calculator and do your maths, you're going to have 11.36 grams of pH3, will be produced from 10.35 grams of P4, according to this balanced equation. All right, having said that, we're now going to go to the last problem here. In this last problem, exactly we're following the same steps, exactly the same step. So the question says, calculate the mass, this time the mass of P4 needed to produce 22.0 grams of pH3. So look at what we're doing now. We're going from mass or grams of pH3 to mass or grams of P4. Basically the opposite of what we did before. That's what we did. And remember, we calculated the molar mass of these two in the previous page. If you want to see it, please go to the previous page. So here I'm going to make it fast. I'm just going to start with what we're given, right? We have all the conversion factors already stated like in the previous one, but we're just doing the opposite of that. So let's start with what we're given. We're going to start from 22.0 grams of pH3. To convert it to moles, we're going to remove grams. We know that a mole of pH3 will be equal to, this was already done in the other one, has 34.00 grams of pH3. This we cancel this. So I'm just going to write this. So just to let you know, the molar mass of pH3 is 34.00 grams, and the molar mass of P4 is 123.88 grams per mole. These are all grams per mole. This is grams per mole. So now that we're here, we want to convert from mole of pH3 to mole of this guy to mole of this guy. What is the mole ratio? Since we want to eliminate pH3, now it's going to be on the bottom. So it's going to be a mole of P4 over 4 moles of pH3. This will cancel this. And finally, when I want to remove mole of pH4 and convert it to molar mass, what is the molar mass? The molar mass of this guy is this. So it's going to be a mole, of course, it's going to be down, P4, so it will cancel. and the molar mass is going to be on top, 123.88 grams of P4. If we did that and did our multiplication right, we're going to actually get 20.0 grams of P4. That will be our final answer. And again, we finished with the longest process, which is converting from mass to mass of one reactant or product to another. All right, and having said that, we've come to the end of this lecture. Thank you for listening. Bye at this point in time.